G'day! Here's a typical and very technical textbook question. It goes as follows. Please consider y equals 2x squared minus 8x plus 6. And let's do the following things. A, find its vertex. B, find its line of symmetry. C, rewrite the equation in vertex form, whatever that means. D, sketch a graph of the equation. E, find its x-intercepts. And finally, F, find its y-intercept. That's a lot. That's a lot going on there. All right, here's my first piece of advice. Just because someone asks you a list of questions in a certain order doesn't mean you have to answer them in that order. Now, I'd like to think drawing pictures really reveals everything. Pictures make everything so much simpler. So I can actually skip straight to the picture part of this question, which is D, sketch a graph of this equation. Because I bet if I have the graph, everything else will fall into place. And we know how to graph quadratic equations. So here's y equals what? 2x squared minus 8x plus 6. I know it's going to be a symmetrical U-shaped graph somewhere in the plane. And the way to identify where it is to look for two interesting x values that are going to yield two symmetrical points on the symmetrical U-shaped graph. That's the trick. All right, so how do I do that? Let me focus on the x part. So I'm looking for interesting x values. Let me focus on the x part of that equation. And what can I do with that? Well, I see there's a 2x squared and a negative 8x. They both have a 2, and they both have an x. They have a factor of 2x. So let me pull out that factor of 2x, and what gets left behind? 2x times x makes 2x squared, minus 4, I think it is. 2x times negative 4 is negative 8x. Yes, that's good, and I still have the plus 6. All right, because when I do that, I now see that x equals 0 and x equals 4 are interesting. When x equals 0 and x equals 4, I bet something interesting is going to happen. In fact, when x is 0, y would be 2 times 0 times stuff, so all that's 0, plus 6. Y is 0 plus 6, it's 6. And when x is 4, y would be 2 times 4 times 0. Oh, all that is 0 plus 6. Y is 0 plus 6, which is 6. Bingo. I've now got two symmetrical points on a graph that I know is going to be symmetrical. So let me start graphing this thing. Let me start graphing this, something like this. X and y. At x equals 0, we have y as height of 6. And at x equals 4, y is height of 6, the same height. Beautiful. There we are. Two symmetrical points on a graph I know is going to be symmetrical. Now let me use my common sense. Let's see. So, it's going to be a symmetrical U-shaped graph, something like that maybe, or down below, or maybe it's upside down. But I can see whatever's happening, the line of symmetry is right between those 2 points. It must be right there at x equals 2. Oh, that was one of the questions, wasn't it? Where's the line of symmetry? That was part B. The line is x equals 2. Bingo, we've done part B. Aha. Okay, what next? What next? I need to get the graph. So, I can see it's going to be a U-shaped graph, maybe like that, or maybe it comes down just there, or maybe it goes down low, or maybe it goes up high if it's upside down. But I do know that turning point, that vertex, must be somewhere on that line. All right, so the vertex is somewhere on that line. Where? How am I going to find out where? Well, I guess I can just put in x equals 2. Let's find out where it is on the line x equals 2 by putting in x equals 2. Y would be 2 times 2. Y would be 4 times 2 minus 4. That's negative 2. 4 times negative 2 plus 6. 4 times negative 2 is negative 8 plus 6. Negative 8 plus 6 is negative 2. Oh, it's down here. At x equals 2, it's down at negative 2. So there's the vertex. But now I've got enough to actually graph the thing. Whoa, it must be a nice symmetrical U-shaped graph, something like that. That's a good enough sketch. Beautiful. So I guess I've just done D. Sketch the graph. My answer is C to the left. C to the left. All right, beautiful. A little bit wonky, but hopefully that's okay. That's good enough. Good enough for right now. All right, so actually I see we've answered more. Look at the y-intercept, where it crosses the y-axis. I see it right there. We did it. Actually, we did it earlier on. It crosses at the point x equals 0, y equals 6. The y-intercept is got it. That's f, 0, 6. That point 0, 6 is the y-intercept. We've done that one. We've done half the questions. Have we done any others? What else have we done? Find its vertex. There it is. I found it. Okay, but what point is that? That's x equals 2, y equals negative 2. The vertex is at x equals 2, y equals negative 2. The vertex is right there at that point. Bingo, I've actually done A as well. I've done 2/3 of the problems just by drawing a picture. I love it. What else can we do? I'll rewrite the equation in vertex form and find its x-intercepts. All right, which of those seems easiest? Oh, well, the x-intercepts is where it crosses the x-axis. That's where y is 0. And rewrite the equation in vertex form. All right, okay. That term, I forgot what that means. I never memorized the names of these different things, so I have to think to myself, what could vertex form mean? I'll do C, why not? This is the one that scares me the most, I might as well do it now. Let's see. Vertex form must be something that says the form of the equation. Rewrite the equation. I'm going to rewrite this equation, something about the vertex being very prominent, I guess, in the equation. Okay, so what's this vertex telling me? I can see it's the basic y equals x squared graph, or some steeper version of it, shifted over so that x equals 2, it's behaving like 0, and everything got shifted down. So I can see actually right now, if I look at that vertex, y was really the x squared graph, but with 2 behaving like 0, and then everything was shifted down 2. So I see the equation was basically that. Now I'm going to be a little bit careful here, because if I expand this out, I can see I'll get an x minus 2 times an x minus 2. So I'll get an x squared minus 2x, I get a minus 4x, and stuff. I get stuff. But my point is, I get an x squared. But the equation was 2x squared, not a single x squared. So I'm missing something. Oh, there's a 2x squared. It must be a 2 that's in front. That's the steepness. I was missing a steepness factor. That's the steepness there, which means actually this front number is always the steepness. That's kind of cool, steepness. So it must be, I could rewrite the equation as x minus 2 squared, make 2 behave like 0, down 2, minus 2, and I must have had a steepness factor of 2 in front of all that. Well, okay. There is a same form of this equation, and it makes the vertex very clear. X minus 2 is behaving like 0, and everything's down 2. I bet that's vertex form. I bet that's the equation in vertex form right there. Okay, my board is getting really messy, but here it is. It's going to be y equals 2x minus 2 squared minus 2. Great, done it. What next? What can I erase? Because I need some room, because I've still got that was part C. Part E, find the x-intercepts. All right, let me get rid of that. Let me keep this one on for the moment, because I've got an idea. My brain is already worrying on how I'm going to find the x-intercepts. I already said that the x-intercepts are where y equals 0. So the x-intercepts are where y equals 0. So we need y to be 0. The reason why I decided not to erase this, I've now got 2 equations that I could play with. I could either play with that one, or I could play with that one. And to find the x-intercepts, I want to have y to be 0. I want y to be 0. Let me play with this one first, because I have a feeling I can play with this one pretty quickly. So if y is 0, if y equals 0, then I get that 0 equals 2 times x minus 2 squared minus 2. Oh, my pen's not going to run out. Don't run out on me, pen. Not right now. It seems irresistible to add 2 to both sides. Add 2, 2. Add 2 is just 2x minus 2 squared. All right? It seems irresistible to divide both sides by 2. 1 equals x minus 2 squared. Or maybe I could rewrite that as x minus 2 squared equals 1. Something squared is 1. This is like the box method. Something squared is 1. My something better be 1 or negative 1. Add 2 to both sides. X better be 3, or negative 1 plus 2 is 1. These must be the x-intercepts. Does that look believable? X could be 3. I bet it must be 3. And x could be 1. Beautiful. Turns out it was exactly halfway between 0 and 2. Didn't have to be, but turned out to be that way. And it turned out to be between 2 and 4, namely 3. Perfect. I found the x-intercepts. Now, of course, I could have done it up here as well. If I needed y to be 0, that means I will need 2x squared minus 8x plus 6 to be 0. It seems irresistible to divide everything by 2, because I don't like that 2 in front. X squared minus 4x plus 3 equals 0. And I bet if you did our usual algebra box method on that, you'll end up back down to there. And it'll be the same. In fact, it could be fun to check that out just for fun. I mean, we found the answer already. The x-intercepts are, 1, 0, and 3, 0. But we've got a nice couple of ways to get to it. Either do the standard box method on the first equation, or play with this version, which actually kind of, check it out. You'll see it's the box method again. All right, well that was speedy, but there it is. We did all 6 parts. I love the fact of drawing a graph made so much of that make sense right off the bat. I could see what's going on, and I answered, what, 2/3 of it right off the bat. Brilliant. So I'm going to actually erase this board, and let's do another one. In fact, let's do a variation of the same question just to practice that again. I'll show a screen with a question. You can pause the video, try it out first, and then watch me do it all again as well and see if we get the same answers. We'll compare notes. So I'll be back in a moment. Okay, I'm back. So you see I was asking the same 6 things again, but now on a different equation. Y equals negative x squared plus 2x plus 3. So let me go through it now. I'll go quite quickly and we'll compare our notes. See if you got the same things that I did. All right, here goes. Of course, I'm going to always draw a picture first. A picture speaks 1,000 words. Makes life so much easier if you just draw a picture. Everything falls into place. We're looking for 2 symmetrical points on a symmetrical graph. That is, I'm looking for interesting x values. So let me focus on the x part. In fact, let me pull out a common factor of x, and I see there's a negative x left behind and a 2 plus 3, negative x squared plus 2x, yes, and plus 3, great. I now see that x equals 0 and x equals 2 is interesting. X equals 0 and x equals 2, they're both interesting. Whoops, I'll do that. At x equals 0, y would be 0 times stuff, 0 plus 3 is 3. At x equals 2, I get 2 times 0, that's 0 plus 3, y is 3. There we go, 2 symmetrical points right there, found them. Let me start sketching. X-axis, y-axis. At x equals 0, I'm at 3. At y equals 2, I'm at 3. All right? 2 symmetrical points on a symmetrical graph. I can see the line of symmetry has to be right down in between them at x equals 1. Line of symmetry must be x equals 1. Did you get that? Did you get that? Y-intercept, I can see it right there, is the point actually 0, 3. Bingo, 1 done, 2 done in this bright yellow. What else can I say right now? Not much. I think it's all so far so good, but I do know the vertex is somewhere along there. And how high is that vertex? I don't know until I put in x equals 1. Let's do it. Put in x equals 1, out comes y equals 1 times negative 1 plus 2. 1 times 1, that's 1, plus 3 is 4. Ooh, it's 4. It's higher at 4. Oh, which makes sense. I'm expecting something upside down because that's the steepness. All right, I did expect an upside down U-shaped graph, and I think I've got it now. Here is the graph. Whoa, a nice U-shaped graph like that. Beautiful, beautiful. Sketch the graph, done. C to the left. All right, now, okay, what else can I do? Find its vertex. There it is. At x equals 1, y equals 4. At the point 1, 4. Oh my goodness, very good. Grand, grand, grand. Rewrite in vertex form. I will do that one now. It must be, I can see, okay, this graph is basically y equals x, x equals 1 is behaving like 0. So 1 is behaving like 0. Everything's up 4 places, but the steepness is negative. I bet this is it. I bet if you expand out the algebra, that will be it. That will be it. Check me, if I expand that out the algebra, I bet it's going to be the same as that. Grand. There it is. That's rewrite in vertex form is there. I guess C left again. C left. And then finally, it's X intercepts. I'm going to play with this one. I think putting y equals 0 is going to be easy for that one. For y equals 0, so if y is 0, we have 0 equals negative x minus 1 squared plus 4. Let me add this quantity to both sides. So I get x minus 1 squared is 4. Something squared is 4, so my something is either 2 or negative 2. Add 1 to everything, x better be 3 or negative 1. Beautiful. Does that seem believable? Oh, it does actually. X is either 3 for that point or negative 1 for that point. So beautiful, that means the x-intercepts are the points negative 1, 0, and 3, 0. My handwriting is getting particularly bad now, but I think we've just done it all. That is the power of symmetry. That is just amazing. Look for two interesting x values that lead to symmetrical points, and everything else was just following your nose and things fell into place. You could do the box method here for the x-intercepts, play with that one, and I bet the box method leads to that equation as well, because it's all interconnected, it's all beautiful, and it's actually kind of fun in the end.